Alright, looking at number 147, wanted to highlight the composition of functions to show that f and g are inverse functions. So the first definition we need to know is that if they are inverse functions, that f composition g of x, whatever we put in g, whatever comes out puts into f, we should get the x back out. That's our definition of inverse functions. So to show, we want to put g of x into all the x's in f of x. I definitely wanted to highlight this one because we've got a lot of simplifying a complex fraction once that goes on. So what's that going to look like? I'm going to put the whole g of x right there and right there. So let's make sure we do that first. Negative 3x minus 2 over x minus 1. I'm right there, minus 2. Over, now I'm going to put the whole thing where that x is, negative 3x minus 2 over x minus 1 plus 3. So that's the whole thing. Now, we've done the complex fractions in class. Our move here is, if I've got a denominator of x minus 1 there and a denominator of x minus 1 there, if I multiply the entire by that big giant 1 from Algebra 2, our top and our bottom, everything's going to start cleaning up. So that's the move we want to make. So I'm going to multiply this whole numerator by x minus 1. I'm going to distribute it here and here. And I'm going to multiply the whole denominator by x minus 1. I'm going to distribute here and here. But what happens in this numerator when I distribute the x minus 1 to the first fraction? It's going to go away with the denominator. So I'm just going to be left with a negative 3x minus 2. Then, when I distribute the x minus 1 to the negative 2, I'm going to get negative 2 times x minus 1 here. Over, same thing, x minus 1 here crosses out there, and I'm left with the negative 3x minus 2 plus 3 times x minus 1. Now, one mistake not to make is we'd never just cross off this x minus. We wouldn't do that. We want to make sure we do the whole thing and do simplifying all the way down. So I'm going to distribute through here, distribute that negative 2, negative 3x minus 2 minus 2x plus 2. Our denominator is going to be negative 3x minus 2 plus 3x minus 3. Now as we look in the denominator, those are going to add to 0. So I'm going to be left with negative 5x. And my numerator, or my denominator, will be, this one's going to go away, I'm going to be left with a negative 5. That's where negative 5x divided by negative 5 is equal to x. So now I've shown that f of g of x is x. Now I would definitely challenge you to go through and go the other way. Can you put g of f of x? Do all of the algebra simplifying, and can you get it back down to x? That would be the challenge.